Here's a conditional probability question. Whenever you get a conditional probability question in an exam, the main decision you've got to make first up is it a Venn diagram question or is it a tree diagram question? I think this is fairly obviously a Venn diagram question, just because the idea that someone could choose one or more of the options is a scenario. Whereas in a tree diagram question, it's like you have to choose one of the things, and then another round happens and you choose one of the things again, and so on. Whereas in this question, clearly someone can like apples and oranges, or bananas and apples and oranges. There's a combination which is allowed, therefore I think it'll obviously be a Venn diagram question. So I'll just draw out the box and the circles, and then we'll start going through the data. I think always start off in the middle. So apples goes here, bananas and oranges. Okay. First of all, 11 people like all three fruits. So I'll just put 11 in the middle. 33 people like apples. I'm going to leave that for now. I'm definitely not going to put 33 here, because if that was the case, then I'd be saying actually so far 44 people like apples. It says 33 people like apples, but not 33 people like apples only. So I'm definitely not going to put 33 there right now. So I'll skip over that one and come back to it soon. 6 people like apples and bananas, but not oranges. That's okay, then I'll put that here, because that's that section. 15 like bananas and oranges. You've got to be really careful here. I'm not going to put 15 there. The section that describes the people who like bananas and oranges is actually both of these sections combined. So therefore 11 plus the number which goes in here must add up to 15. Therefore the number which goes in there must be 4. I mean, look, it says that 15 people like bananas and oranges. It doesn't specify whether or not they're allowed to like apples too. If it says 15 people only like bananas and oranges, then fine, you can put in this section. But it doesn't specify that. So it's going to be 11 plus some mystery number equaling 15. Obviously the number is going to be 4. Okay, 5 of the people do not like any of the fruits, so clearly I'll put 5 outside. All 25 people who like oranges like at least one fruit. Okay, so inside this circle, there must be 25 people. Therefore, 11 plus 4 equals 15, and 15 plus the number which goes in here must equal 25. Clearly that number will just be 10. I know that no one will go in here because of literally what it says. All of the people who like oranges like at least one other fruit. In other words, there's no one who likes only oranges. Okay, now we'll go back a little bit. It says 33 people like apples. So 10 plus 11 is 21, plus 6 is 27. So 27 plus this number must come to 33. Therefore, this number must be 33 minus 27, giving you 6. The only section we're missing now is this section here, the people who only like bananas. And what I'll do now is just look at everything I've got and acknowledge that 50 people were asked. So I've got 5 plus 4 is 9, plus 11 is 20, plus 10 is 30, plus 6 is 36, plus another 6 is 42. Therefore, the remaining 8 people must go into the category of the people who like only bananas. The question itself says 2 of the 50 people are chosen at random. What's the probability they look both like bananas? This is conditional probability because the result of the first round will affect the probability of the second round. On the first round, the number of people who like bananas is everyone in this circle here. It's definitely not just going to be 8. It's going to be 8 plus 4 plus 11 plus 6, which comes to 29 out of a total of 50 people. So that's the probability that that the person chosen in the first round will like bananas. And then to choose another person in the second round who likes bananas, given that you've already chosen one person in the first round, has to acknowledge that that 29 goes down by 1. So now there are only 28 people who like bananas. But it also has to acknowledge that one person is now missing from the total group. Therefore, that 50 has to go down by 1, giving 28 out of 49. Doing this calculation, you get an answer of 812 over 2,450. This answer can be simplified, but the unsimplified version is 812 over 2,450.